I'm Anil Kumar sharing with you some questions of my student Melissa. Now I hope these explanations help her and all of you to understand how to apply sine law and simplify the solution to the given questions. Question here is: hobbyists often compete with the model rockets to determine which rocket flies the highest. On one test launch, a rocket was fired vertically upward. The angle of elevation to the top of the flight was measured from 2 points that were 20 meters apart, on the same side of the launch site and collinear with it. The angles measured at the 2 points were 66 degrees and 37 degrees. How high did the rocket fly to the nearest meter? So what we are given here is, let's say that is the rocket launched vertically upwards. We need to find the height. From 2 points, let's call these points as A and B. Angle of elevation was measured to be 66 degrees and 37 degrees, and these 2 points are 20 meters apart. So we need to find height in this case. Now we have discussed when we were working on right triangles how we can do it with tan ratios. Well, that's a lengthy proof. Now in this particular case, we can actually use sine. See how. We can actually find this angle. 66 is the exterior angle. Therefore, that angle should be 66 minus 37. Got it? That's one way of doing it. The other way of finding that angle is, think about a horizontal line here. In that case, that horizontal line and the ground horizontal line will be parallel, and the alternate angles will be, the big angle is 66. The small angle is 37, and their difference is this angle we are talking about, correct? So we know that this angle here is 66 degrees minus 37 degrees, correct? So we can use the calculator to do the needful. 66 minus 37, 29 degrees. So let me write 29 degrees here. So that is how we have the missing angle. Now we know the ratio 29 to the side. Once we know that, we can find the sides of this triangle. Since we need to find the height, that is the side which is critical for us. Let me call this side as small a. Okay, let me call this side as small a, side opposite to my angle a. Okay, so let's solve for this. So first thing, let me call this point as the rocket R, and this is O for us. So we say that the angle ARB is equals to 66 degrees minus 37 degrees, and that is 29 degrees. It is important to show all the steps. Now when you apply the sine law, then you need to find the side. So I like to keep that side right on the top of my equation. Sine law can be written in both the orders, right? So A over sine of 37 degrees is equals to 20 over sine of 29. Now you cross multiply to find the length RB, right? So A is length RB. So A is equals to 20 times sine of 37 divided by sine of 29 degrees. So all these are degrees. Okay. So let's find this value. So it is 20 times sine of 37, say equal to, and then divide by sine of 29 equals to 24.8268. So I'll write this as 24.827. Okay, so we got the value of A. Since we have the value of A, we can actually solve for H, right? So we know the angle. Now in this particular triangle, we know we are interested in the opposite side, and we know hypotenuse. Therefore, which sine ratio should we use? We should use sine of 66, correct? So let us use sine of 66 and find the value of height. So we'll do sine of 66 equals to height over A and age, we just calculated that side to be 24.827. Now cross multiply to get the height. So height equals to 24.827 times sine of 66 degrees. So that is how we can do it. So simple, right? I already have this number. I have to multiply this by sine of 66 degrees. That is it, right? So we get 22.68 in meters. Now the question says to the nearest meters. We'll just round it to 23 meters, right? So these are very simple steps to solve such a question when you use sine law, right? So you can check if without using sine law you solve it, it is pretty lengthy, right? So we have a link to that also for you to appreciate how simple it becomes when we solve the same problem using sine law, and later you'll also see when and how to use cosine law. I hope that helps. Thank you and all the best.